I think a good way to tie all of this together is to create a simple reactive data source and see all of the parts moving together. To do this, we'll have three different pieces. The first will be the reactive data source. In this case, it's an empty object right now, and it's assigned to the name variable. The name variable, or the name reactive data source, will work similar to session. So we'll be able to get its value and also set its value. Then we have a function called printName, and the purpose of this function will be to get the value of the name and then just print it to the console. And the goal will be to rerun this function anytime the name changes. Then the third part is we create a computation by calling the autorun method and then call the printName function from within this computation. So what we want to do is when the name value changes, we want to invalidate this computation as well as any other computations that use the name value and cause the functions to rerun. So I'll start off by filling out the printName function. We'll create a variable called name and assign it to the value of name.get. So that will get the value of name from our reactive data source, sort of like session.get. And then we'll just print out the value to the console. Next, on the name object, let's create a get function. And the get function will just return the value. And I'll create a value property that's initially just set to null. And then we need a set function so we can change this value. And finally, up top, I'm going to create a property called dep, and I'll assign that to a new deps dependency. And this will let us track the computations that use this name value. Okay, so here's the trick. Inside of the printName function, when we call this get function here, we're calling this function inside of a computation, and that computation was created by calling autorun. So when printName gets called, a computation has already been created. And so what we want to do is inside of the get function, we want to keep track of this computation and store it in our deps dependency list, so that later when the value changes, we can invalidate that computation and cause this whole function just to rerun. So inside of the get function, we could get a reference to the current computation by calling deps.current computation and then adding that manually to our dependency list. Or we can just call the depend method of our dependency. And that will automatically grab the current value of a computation and store it in the list if it doesn't already exist. So now that we've done that and our code has refreshed in the browser, let's type out our name object and take a look at the dependency. And now you should see that we have one computation stored in the dependency list. And that's because we called depend on the dependency, which added this computation down here to the dependencies list. And to make it even more clear, let's create another computation by calling autorun again. And we'll just print the name here as well. And back over in the console, you can see the name gets printed out twice. But if we take a look at the dependency object of our name reactive data source, you can see now that it has two computations in its list. So the next step is that if we change the value of the name, we want to invalidate each of these computations. And we can do that by calling the changed method on the dependency versus iterating over each of the computations ourselves. So inside of the set function of the name reactive data source, I'll call the changed method of the dependency. And then if we come over into the browser, I'll call name.set, and let's change the name. And now you can see that our print name function is run twice because we have two auto runs, and the name now has been updated to the value of Chris. Now, one problem with our current implementation is that if I set the name again to the same value, the computations are invalidated again, even though the value hasn't actually changed. So let's fix that in the code. What we can do is just create an if statement, and we'll check whether or not the old value is equal to the new value. And if it is, we'll just return. Otherwise, we'll set the value and call dep changed. And if we go over to the browser, let's just check that it works. And I'll use the same name again, and this time the computations aren't invalidated because the name is the same as it was before. We created this simple reactive data source so that you could get more intuition about what's going on. But there's also a package that comes with Meteor Core called Reactive Dict, and it contains an object called Reactive Dictionary. You can use this package in your applications. It also happens to be exactly what session is. If you were to look at the session package, you would see it's an instance of a reactive dict. You can study this implementation to see some of the extra features that it adds, and you can see that it's a bit more complicated than what we just implemented, but the principles are the same. So hopefully in this episode, you've gained a better understanding of what it means to be a reactive data source, and how reactive data sources are able to work with computations to rerun functions when the values of the reactive data source change.